Well, so today we're going to discuss about the performance tuning. So this is the last class for this training, and the performance tuning is something which is a, I don't say it's a day-to-day activity, but somewhere every frequent we get these type of issues from application team of or developer team asking us that the server is not performing well or the database is not responding properly. So in those cases, how we need to troubleshoot and what all the things we need to check and what is good and what is bad. So we try to understand a bit of it because in general, performance tuning it itself takes a month of time to discuss in depth about what a performance tuning, how we can tune in depth on all the things. I would like to cover all the major tools and the techniques and where all we need to check. But if you still want to know about in depth for each and every topic, you can go and you can do some research on that. So generally performance will be related between three resources, irrespective of whether you are running a SQL Server or Oracle or your personal machine. So every system will depends on a performance resources. So in general, they are CPU, RAM, IO. If any of these three resources are not working properly, then you notice your server will degrade the performance. If your server is running or if your local machine, your personal machine is running at 100% CPU, you see that all your applications will get hang up, right? And the same way, the RAM, the memory on your server, you don't have an efficient memory on your server that can handle the workload on that instance. So then still it puts load on the server. It degrades the performance. And if IO is a bottleneck, let's assume the storage that been attached to the server is not efficiently configured, or the storage is not efficient, is not in a speed rate to push and pull the data as per the request. So during that time as well, if any user is trying to execute any query to pull out the data from your database, so your SQL Server has to go back to the drive and pull the data from the MDF files and display those results back to the user. And if your data drive is not configured efficiently, or if your storage is not up to the mark, then obviously your SQL Server will take more time to fetch the data from your MDF file, and it gonna take more time for the end user to see the results. So these are the three main areas which we need to think of whenever you are running into performance issues. And especially if it is a SQL Server, then we need to think of one more resource that is called TempDB. The TempDB, we already know that it is one of the system database and it holds the temporary information. Like if a user is trying to rebuild an index, or if a user is trying to pull out a huge amount of data by doing a sorting, he is trying to pull out huge amount of data with order by. So this order by and aggregate functions, the average, sum, minimum, maximum, all these aggregate functions and order by classes will be taken over by the TempDB. Your SQL Server will use the space in the TempDB to perform all these actions. If your TempDB is not configured properly, then obviously you notice your SQL Server will take more and more time. So it is one more important thing that we need to configure our TempDB database in such a way we get a good IO. So the best practices for TempDB from Microsoft is we need to have multiple TempDB database files. Multiple data files. By default, TempDB contains one MDF and one LDF, right? But having said that, if you have got 20 databases on the instance and assume 10 users per each database, so in total we are getting 200 connections simultaneously on your SQL instance, and assume all those 200 users are trying to generate a report by doing some aggregations and by doing some sortings. So all those 200 connections require 10 TB data file to get those work done. And as you have got only one 10 TB data file, your 10 TB will only take the first request that is coming in, and it performs, and then it takes the second request, and it does in a first in and first out. So the last one, the 200th user, has to wait for a long time to get his query executed. So to avoid all these details, Microsoft recommends us to create multiple data files for 10 TB. So when I say multiple 10 data files, then the next question is how many? What is the best number we have to create? So the Microsoft does have a calculation for that. So what Microsoft says is create multiple data files depending upon the number of cores you got on your server. Cores are nothing but the CPUs. So in real time, we have multiple core servers, 4 CPU server, 8 CPU servers, 16 CPU servers, 32 CPU servers. So if you have got a 4 CPU server, so in that you already have one data file by default. So you need to create 3 additional data files. So in total, we will be having 4 data files, and your CPU will pick up the worker thread. Whenever a request comes to the SQL, your CPU will issue a worker thread, the processor, and that processor will execute that query and gives back result to the end user. So now we have got 4 CPUs on a server, so simultaneously SQL can do 4 processes at one time. So now we have 4 data files. So SQL can send the 4 requests to 4 different files. So by implementing this, we are reducing the load or the time by 4 times. And if you have got a 8 CPU, then we need to create 8 data files. And anything beyond 8 CPUs, still we need to restrict at 8. Maximum we need to create is 8 10 TB data files. Even though your server has got 16 CPUs or 32 CPUs, Microsoft says restrict or limit with 8 data files. Don't go behind 8 data files. You won't get better performance. So that's the one of the thing we need to remember before or while installing a SQL Server. And let us try to understand each of these 3 resources. We have talked about the 10 TB, now the CPU, RAM, IO. I don't think I need to give an introduction to these 3. We are very much familiar about our CPU, RAM or IO. So but still, if something is wrong, if something is going phishing, I mean your server is not responding properly, so we need to identify where the problem persists. Venkat, how to create multiple data files? See, you need to go to your management studio. And one more condition is, while you create your 10 TB data files, the other condition is you need those files should have identical size. All the 10 TB files should have same size, the unique size. Okay, that is a one more important point to remember. So in order to add a file, either you can go and add it using a GUI. You can go on to files and you see you can click on add and just keep on adding. If assume my machine has got 4 CPUs, then just click on add 4, and whatever the size you see for the first data file, you need to ensure the same size for the next newly created files. So ultimately we should have the identical size on all those. Well, so the next point is we need to narrow down where exactly the issue is with. Issue is with the CPU or RAM or IO. So we know that there is something, I mean, if your server is not performing well, there could be something wrong with either CPU, RAM or IO. But still we need to find out what exactly the problem is, where the problem lies. Is it with CPU, RAM or IO? So to identify that, we have multiple tools. In real time, if you have a third-party monitoring tool, then that particular tool will send alerts to the DBA team in case of any abnormalities on the server. If your CPU is spiking high, and you have a third-party monitoring tool, then you're gonna get alert from there. So there are some third-party monitoring tools, something like Diagnostic Manager and Foglight, SCOM. So these are third-party monitoring tool where you can install the software on your server, and you can register your server on this tool, and you need to configure the alerts and responses, and then after you will start receiving the alerts whenever your server is running under pressure. Now Nita, you need to refer back to the system databases. I clearly said that we cannot take backup of TempDB. The data in the TempDB is a temporary purpose. We can't take backups of TempDB. On the last class, we are discussing about the topic of the first class. So there's a reason I request everyone to go through the previous sessions. So apart from this third-party monitoring tools, we do have inbuilt tools in SQL Server. I can say in Windows operating system. In Windows operating system, maybe even in your machine, you can use those tools like Perfmon. This is a Windows tool. You don't need to buy it. It comes along with your operating system. And there's a one more tool called SQL Profiler. This tool is very specific to your SQL instance. The Perfmon is a Windows tool, and you can monitor what all the things going on this server. Assume your server has got SQL Server software. Assume it does got Oracle, or it also got some C#. So if multiple applications are running on a single server, then you can use Perfmon to monitor entire thing on server level. And if you are very specific to know about specific to SQL, you don't bother about the remaining applications that are running on your instance, but you are very specific to SQL Profiler, then, if you are very specific to a SQL Server, then the other tool you can use is a SQL Profiler. You can use this SQL Profiler with a SQL Management Studio. You need to install your SQL Server, and you need to connect to your Management Studio, and from there you can use the SQL Profiler. So you need to have SQL installed in order to use SQL Profiler. And what this SQL Profiler does is it has a mechanism to capture each and every minute thing that is running on your instance. A query that might be taking a 0.1 millisecond. So it would be very hard for us to capture using sp_who2 or activity monitor. So but those things can be captured by using a SQL Profiler. So before I jump more onto SQL Profiler, let me show you how the Performance looks like. So in order to open a Performance, you need to open the Run window and just type Performance and click on OK. On left hand side, you can see a performance monitor. You can click on it and it will give you a graphical picture over here. Under here, by default, it is showing a processor time. That is nothing but your CPU, how much CPU being utilizing now. You can see my CPU is running in between 20 and 30. Okay, but it's not only enough for us. We still need to capture the events for RAM, that is a memory on the server, and the disk IO, how the data being pulled and written onto the disk. So in order to add more things, you can, on top you can see a plus sign. Okay, you can just click on this, and here these are the events. On top you can see this is a local computer. That means you can monitor all the things that are running on your machine. You still have a feasibility to monitor a remote server. You can provide the remote server name here, and you can monitor the things that are running on your remote server. What is the permissible value? If it is for CPU, we always think what is the less that would be good. If your CPU is running in between 80 to 100% continuously, then there is something going wrong. I don't say every time it is wrong. Probably we are putting more load on the server. That is the reason your server is taking 80% or 90% CPU. But we need to understand, is it really a huge load that we are giving onto a server? I can give an example. We know that we have to run maintenance plans regularly on the databases. The index rebuild, update stats, and reorganize indexes and integrity checks. Okay, and you have got a server, and that server has got around 20 databases, and those databases are very huge. Each database is around 200 to 300 gig. Okay, so we have got 20 databases with huge size, and if you are running the integrity checks or the index rebuilds, or you have update stats, if you run this, obviously your server will go up to 90%. So we need to understand what we are doing and what is the capability of the server and how much load we are putting on it. But always above 90 is a risk factor. We need to look at it. And whatever below 30, 40, 50 is still, that's okay. You don't need to bother about that. So the first is the processor. We have seen that process already included here. So you can see 0, 1, 2, 3, 4. So what it means is I have got 4 virtual CPUs on my machine. Okay, there will be a physical CPUs and virtual CPUs. So I have got 4 virtual CPUs. That was the reason it was giving a 4 numbers, and we already got a processor, so we need to look at something about the RAM memory. So if you scroll down and up, you can see there are some events specific to the SQL Server as well. So by sitting at Performance, you can still monitor the things that are running on your SQL Server, but not exactly as SQL Profiler. SQL Profiler does capture very minute and all the backend things. It will give you the more things at SQL side, but still you can use Perfmon to find out the basic events. So I go back to memory. Okay, let me check the buffer manager. This is a, I mean, in olden days we used to monitor the buffer cache hit ratio. This is one of the event we always try to look at it, and this would give us a statistics like, okay, whether your RAM is doing good or not. So this buffer cache hit ratio should be always very near to 100, so 99.99. If it is below 95%, then your buffer, whatever the RAM you have, is not sufficient. That was the initial thing said by Microsoft to monitor the buffer cache ratio, but in my past experience, even though I have memory issues, the buffer cache hit ratio still shows as 99%. So it doesn't make sense for me. So that's the reason I'm just skipping out. The one important thing is the page life expectancy. This is a very good option, and it gives you a clear idea whether your memory is running under pressure or not. So the page life expectancy, what it is, when a user writes or when a user executes a query to read a data from a table, okay, if that is the first time he's executing the query, then SQL, what it does is it picks up that query, it goes back to the database MDF file, that is which is located in a drive. It goes back to the drive and then pull the data from the MDF file, and it will give that result to the end user, and a copy will be kept in a buffer. Okay, the result will be given to the end user and a copy will be kept in a buffer. It's nothing but a RAM. So what is the intention? Why your SQL Server will keep a copy in the RAM? It is because if the same user come back again and re-executes the query, then SQL will check whether the query is same or not. What are the query he executed before and now, and those queries are same or not. If it is same and if the data not changed, then your SQL Server will directly pick the result from the buffer and give it back to the user. It don't go back to the drive and pull the data. So it will give you efficient results. I mean, SQL, if it has to go to the drive, the MDF file and pull the data, it will be more cost to the server. So by keeping a data, the pages which were pulled out by a user earlier, so by keeping all those page information in a buffer, so it would benefit if a user comes back and re-execute the same query. So what this page life expectancy gives is how long my page is in buffer. If I have executed a query now and I pull the data and a copy will be kept in a buffer, and that data, for how long it is being kept in that memory. So that is what the value for this event, page life expectancy. The more the time your date, the more time the pages in your buffer, it's a good thing. If whatever the data you pulled out and a copy will be kept in a memory, if it is for more time, then that indicates it's a good, your RAM is much more enough to keep your pages for the more time. On the other side, if you think that the whatever the data you are pulling out and keeping in a buffer is flushing very frequently, okay, assume that my RAM I have got only 4 GB of RAM, and continuously there are around 100 to 150 users hitting the database and trying to pull out the data. If I'm the first user, I'm executing a query to pull out 10 rows from a table, so those 10 rows will be kept a copy in a buffer, and then a result will be given to me, and later after an hour, okay, after an hour I went back and executed the same query again. But during that time, my page, if it is available in the memory, then your SQL Server will respond back it in very soon. Maybe for the first time it might take around 10 seconds to execute your query, and if you re-execute the query again and the data is in memory, then SQL Server will give you the results in 4 seconds. So that's the benefit of having your data inside your buffer, inside your memory. If there is a huge transactions happening on your database and you don't have much memory, then your RAM will keep on flush the old data to accommodate the new coming data. So in that case, even though you executed your query for the first time in 10 seconds, and the next time if you re-execute it again, it will take the same 10 seconds because your page no more exists in the memory. Again, your SQL has to go back and pull the data from the MDF file. So that's the importance of the page life expectancy. If you see a value below 3000 for a page life expectancy, that is a 3000 seconds, that means you are or your memory is running under pressure. Earlier days, Microsoft used to say like 300, but most of the Microsoft experts says that's a rubbish. 300 is rubbish. As per the now, in today's infrastructure, the hardware infrastructure, to 300 is nothing. We need to have at least 3000. That's what the most of the Microsoft experts says. I'm going to add a page life expectancy, and one more thing is we need to have where is the memory? This is the memory here. And one more thing I would be interested to pick it out is available megabytes. I would like to add it. Available megabytes is something, if you have a RAM of 10 GB on your server, then how much amount of free RAM available. So among 10 GB, how much being used by your SQL Server and how much is still available. So always Microsoft says we should have at least 1 GB of RAM free and available. So that is the reason I'm more concentrated to find out the event to see if I have got 1 GB of RAM at least free. So this is for memory, and we already have a processor. So let me add it again. Processor, okay. Processor time, and then we check the disk IO, the physical disk. It should be with P. Okay, this is a physical disk. So the events you can see here, there are a lot of events available, some thousands of events available, but I'm only concentrating on the few ones that are majorly used. So the disk reads per second, writes per second. Okay, disk reads per second, disk writes per second. So as it sounds, it does the same. How many reads were happened in second? How many writes were happened in a second on the drive? So if you have a very bad storage, it's gonna take more time to perform reads and writes. So we should have, especially for production servers and for OLTP databases, we should have efficient, fast storage. So I do want to have average disk queue length. Okay, this is the one. So what this gives you is average disk queue length. It's something how many requests are in queue for the disk. I repeat it again. Average disk queue length is nothing but how many requests are in queue for the and in queue and waiting for the disk. And if you notice this value is more than 2, number 2, then it clearly says there's something wrong with your storage configuration. So we need to check with our storage team to ensure that we have got efficient and very good configuration for storage. So this is all I need to find out or to narrow down whether the issues with the RAM or CPU or memory. So you can click on OK, and it does give the information of everything, but it's very tricky to find it out. So you can change the glance. I think we don't like to look at this way. It would be very hard to notify what is what here, the color. So you can change the view by clicking on here, and you see report. So it does give you a clear information like how your SQL or how your SQL Server is performing. You can see available megabytes. My available megabytes is around 4 GB, so I'm very much good at it. And the page life expectancy, it's showing 0. Probably my SQL Server service is not running. So it's SQL 2012 named instance. So let me run it. Okay, you can now go and check this one. So you can see it's keep on getting increased. Now what I do is I'll just execute a simple command. The SQL 2012 instance. I'm just executing a query. Okay. So now whatever the information I pulled it out, right? So this information, before it produces to me, a copy will be kept inside a RAM, and that information will be kept for the time it was showing here. It will be in seconds. It's keep on increasing. I've just started my SQL instance, so it's just capturing all the required information in the RAM. And the average disk queue length, having said that, this should not exceed a number called 2. And the disk reads per second and disk writes per second. As of now, it's my local instance and I'm not running anything over there, so it's almost clear, very near to 0. But in real time and for OLTP databases, you might see around 100 or 200 writes per second or reads per second. And the processor time is something, your CPU time, how much CPU percentage you are currently running on. So you can check it by going to a task manager, and you can see here this is the CPU, and the same thing will be listed over here. And the memory, disk, and network. This is a one more tool, task manager. By using a task manager, you can check how your CPU, memory, disk, and network are running. But quite few people says that we can't really rely on task manager. Sometimes task manager will mislead you. It won't give you the exact information. So probably you can reconfirm those things by using the Performance tool. And inside this task manager, if you go on to performance, and at bottom you see open resource monitor, you can click on it, and here you have got couple of tabs: CPU, memory, disk, and network. This is very general. I don't go in depth about these because it's not very specific to SQL, but in general, even though you have your local machine or any other softwares you're running, this is very general things which we need to look at it. So the performance, this is how we try to monitor. And then after, SQL Profiler. For SQL Profiler, you need to connect to a Management Studio, and then you need to go to Tools, and you can see SQL Profiler. Click on it, and you need to connect to the instance for which you want to monitor the things. So probably I will select the default instance, and here the first is a trace name. The the SQL profiler, what it does is it keeps on monitoring the things that are executing on your SQL instance, and those information will be recorded either onto a SQL table or onto a file. Okay, so that's what this information. If you want to save the trace information, whatever being captured, if you want to save onto file, you can select this, or if you want to capture those things onto a table, you can select this one. So the first is a name. You need to provide any name, and then for which instance you are running your trace file, and it will just give you the SQL version and version number. And the next is you can see the use template. By default, Microsoft has come up with templates, so you don't need to bother about what events you need to select. Okay, so you have got T-SQL, you have got T-SQL duration. That means if you want to find out a long running queries, you can browse to the SQL duration, and if you want to find out logs, what all logs were happening on your SQL tables, you can go with this. And if you want to fine tune, or if you want to check the SP's performance, you can go with T-SQL SP's. And the last is a tuning. If you want to tune any query, or if you got to know that your database is not performing well, then you can just please select tuning. Okay, and then after, on top you can see event selection. Go on to event selection, and by default you can see these are all pre-checked. So that is what the use of template. I have used a tuning template, so that's the reason these are all pre-checked. If you think these 3 events is not enough, I need more events, so then you can see an option here, check mark, just check show all events. Then it lists out all the events that are available in your SQL instance. So if you want to monitor the deadlocks, I just explained the deadlock in a moment now. So probably you want to find out if there are deadlocks, then you can go with the deadlock option here. And once you are done with all these things, and when you click on run, then this particular trace will keep on monitor the things that are running on your machine, the entire SQL instance. And the other thing is, where's the properties? Yeah. So the other option is, probably the requirement is you have got around 20 databases on the instance, but the issue is with only one database. So by running this particular trace, it does capture the transactions that are hitting all the 20 databases. So you don't need all those 20 databases information. You are only concerned with the one database information, the transactions that are hitting one database. So how do you filter out? You can filter that by using column filters. Once you click here, you select database name, and here you need to provide okay, database name is selected, okay, column filters. It's not enabling, but I will check it out on this. But how you want to filter is you need to come over here and select the database and then expand like, and it will give you a bracket over here. You just need to type your database name for which you are concerned about, and then click on OK. And then if you click on OK, then your SQL profiler will only will only capture the transactions that are running on that particular database. It doesn't capture the things that are running on the remaining databases. So that's the one benefit. So you can see the trace file is currently running now, and if you think, okay, I can stop it, I got to know what I'm looking for, then you can click on pause. If you think you want to pause it, you can pause it, and just beside you can see a stop button. You can stop it if you want to stop the trace. And one more thing we need to remember is whatever we are running here, the trace file, this trace, the SQL profiler trace still puts some load on your server. So what are the information it is capturing here now? How it is capturing? It is with the help of some queries. Your SQL profiler is running some queries on your SQL server to capture all these things. So that is the reason expert says don't run SQL profiler in business hours, in production servers. So it is not good to run SQL profiler on productions in business hours. So this is all about the SQL profiler. And the next tool is, where it is? And the next tool is the DMVs. DMVs is not exactly a tool, but these are scripts or dynamic management views. You have to use some DMVs to capture or to know what's going on the server. This is a one more tool we can call it as, and the enhancement for the profiler. Having said that, profiler is not a good idea to run on production in business hours, so Microsoft came up with the new technique called extended events. It's been introduced starting from 2008 R2, but SQL or Microsoft says going forward, please try to use extended events in place of profiler because Microsoft going to discontinue SQL Profiler from next coming versions. In place of SQL Profiler, you have to use extended events. Extended events are very light. They won't put load as much as the SQL Profiler does. So you can find the extended events at bottom. It's management. You can see extended events. You can expand it and you can find out the system status here. You can do a watch live data to identify what's going on. If you do any transactions on your database, it should display over here. So this was the extended events, a new feature. And the next thing is DTA, Database Tuning Advisor. What this does is, let me give abbreviation for this. I can give an example for a DMV. I've already gave an example for DMV, like when we were discussing about index fragmentation, but I give a different one now. If you want to know how many connections are currently running on your SQL instance, how many people are currently connected to a SQL instance, so in order to know that, we can use a DMV called sys.dm underscore exec underscore connections. You can execute this DMV and it shows you this is the only active connection currently running on, and this active connection is this one, the same query what I'm running now. This is the only connection established to my SQL 2012 instance. And there are quite few DMVs. You need to remember these DMVs for at least for interview purpose, because for interviewer it's an open-ended questions like, can you tell me what all the DMVs you use in your day-to-day work? So at least you should be in a position to tell these request. So it does give some, it's nothing but an extra information from your sp underscore who to. It gives the same information, but there are quite other things were involved and added to this result. And we do have select star from sys.dm underscore exec sessions. So each individual query, you might see that, okay, they're all giving some duplicate things. I mean, connections, request, and sessions, they are giving almost similar, but there are quite few things that changes if you scroll to right side. Just give me a minute, please. Yeah, so these, at least you need to remember these three DMVs, and there's a one more DMV is sys.dm underscore db underscore index physical stats. So this DMV is to find out the fragmentation. Okay. So once we are done with these server level checking, then we need to come to the SQL level and check if there are any blockings happening on your instance. So in order to check the blockings, we need to use sp underscore who to active. I'm just pasting these queries here. If you want, I can send it out this file. So we use sp underscore who to active. That will give you all the active connections to the SQL instance, and at this place you see a blocked by. Okay, so if you notice that there is anything inside this blocked by the SPID, any number, that means, let's say, let me write a simple query here to demonstrate it. Change the database to HSBC. Okay, assume this is user A. Okay, so user A, let me check what all databases this database got, what all tables. Okay, there is a table. Okay, I have got some information over here. So user A, what is trying to do is trying to delete data from table underscore test where id equal to 1, or I say where test equal to Simon. So user is trying to delete the records that are with the name Simon. So I see everything is with Simon. So probably I need to change this. Okay, let it be, no problem. So user is trying to delete all the records from this table. So if I have to create a blocking, in general, users will write query in this way: begin tran. Begin tran is nothing but you are explicitly asking your SQL server that I am starting my transaction. If a user use a begin tran, then he has to use commit tran. It's a mandatory. If he is not using a commit tran, then your table will be blocked. Your table will be locked by this user A for a long time and for the time he executes this commit run. So you always need to ensure and suggest your users that if they are using a begin run, there should be a commit run at the end. So now what I do is I execute these commands. You can see these much rows were affected. Okay. Now there is a user 2, user B on the other side is trying to read data from table. Probably I need to, instead of read, I need to update it. Or okay, you can see I have executed the query. It's keep on executing. It's taking 6 seconds, 7 seconds, 8 seconds. It's not going to give me the results even it runs for an hour. It's because the blocking has happened. How can you check that blocking? You can come back here, re-execute this sp underscore who2 and go to bottom, and you can see it says 52. So user A connection ID is 52. You can see here user B connection ID is 53. Okay, so go back here. My 53 query, user B has executed his query. Earlier it took around a second to give the results, but now it's very near to 1 minute, but still the results are not coming out. So in this case he come back to you, DBA, can you please check my query is taking a longer and longer time. So what's wrong? So you need to go back to your SQL instance and check if there are any blockings. And if you notice something like this, and 53 is a user who has issues, whose query is running for a long time. Why it is running for a long time is this particular 53 user session is being blocked by your 52 user. So who is your 52 user? You can just come back and probably you need to execute sp underscore who2 because it is not active session now. You can go back down. Yep. So the 53 session is being blocked by 52, and you can see 52 is in sleeping. It's doing nothing there. Its transaction executed, but still it had lock on the table. It is not released. It is because the user is not executed commit run. So that's the reason it is in blocking. So in order to check what the user is doing, so at this moment we got to know that the culprit is 52. 52 is blocking all the next coming transactions. Okay, so now we got the culprit. The next is we need to know who is executing that query. So you can find it out in a login column, who is executing that 52 query and what exactly is doing. So if you want to find out what query is executing, you need to issue dbcc input buffer within parentheses provide the session number. That's a 52. And you can see the query. This is exactly same query the user 52 is executing. So by sitting at our side, we can at least know what query being executed by session 52. And we need to go back to that user and we need to explain him, or we need to tell him that his queries are blocking the remaining other transactions. So you need to execute a commit run. I'm just giving an example, but the other thing is the user might not be using a begin run and commit run, but what the query is executing probably is delivering some 10 GB of data, and that 10 GB of data might take around 2 hours to delete. So for those 2 hours of time, all the other users who want to access the table will be blocked. So that's one of the things we need to know if there are any blockings on the instance. So you can see now, as soon as I click on commit, before I click on commit, you can go back here and this query is still running with 4 hours. So I go back and do a commit and you can come back here and the query got executed. So this is how a blocking happens. And deadlock is something like the blocking is one way. User A is blocking user B. So deadlock is something like user A is blocking user B and user B is blocking user A. Let's say I have a query, user has a query, he's trying to delete from table A. I don't have a table A, but just giving an example. And in the same query, he's trying to delete or is trying to update table B. Okay. So user A is trying to, first he executed delete command from a table. It's running, and at the same time user B is trying to delete from data from table B. I repeat it again. User A is executing or deleting data from table A, and at the same time user B is deleting data from table B. These two tables are different, table A and table B. Now user B, what he's doing is inside his query, once the data being deleted from table B, is trying to update a record in table A. This is the whole query the user B is executing. And going back here, the user A is also, what he's doing is, once he finishes with deleting the data from table A, he want to update. He want to update table B. So now already a delete command was running for the first here. So user A got an exclusive lock on table A. Okay. And at the same time, user B is executed delete from table B. So he has got exclusive lock on this table. So I just make it as an exclusive lock here, and table has got exclusive lock. Now in order to finish user A's transaction, he has to update table B. Then only he can come out of this transaction. But table B is currently locked by user B. And the same way, if user B has to finish his complete transaction, that is delete from table, and after immediately he want to update table A, but this table A is already logged by your user A. It's nothing but a cross mark. User A is waiting for transaction for user B, and same way user B is waiting for a transaction for user A. So in this case, at least in blocking, just before whatever we have seen, if a user is executing or deleting 10 GB of data and it's gonna take around 2 hours of time, we can be still assured that the next person can be still assured that, okay, at least after 2 hours I will get a chance to read data from the table, right? But in this particular scenario, this particular blocking is infinity. We can't assume for how long it's gonna take. User B is waiting for user A and user A is waiting for user B. It's a simple example that you have a single track and two trains are coming in opposite direction and you don't have any junctions nearby. So none of them can go forward. So that's the situation, we call it as a deadlock. So in these cases, SQL itself will kill one of the transaction. So it's not going to resolve by its own way any time. So SQL, what it does is it comes into picture and it treats, oh, this is a deadlock. It's not going to resolve even if you wait for an hour or 2 hours or a week or a month or a year. So what the SQL does is immediately when it notices these type of issues, it involves and it treat this as deadlock and it will kill one of the transaction. It will kill either user A's session or user B's session. Let's assume for now it kills user A session. That means it is making a free way for user B to execute his queries. But on what basis your SQL will decide whether to kill user B or user A? Again, it's the best example to take a single track with two trains. If you are in a situation to isolate that issue, you have got a single track with two trains coming in opposite direction and both the drivers are fighting. I won't give you a way to you and you won't give way to me. So both drivers are not compromising there. And if you were given to isolate that issue, what will you do? Which train you want to push it back and which train you want to move forward? The basic thing is our decision will be exactly what is the nearest station. I have got a train A on left hand side and train B on right hand side. I will just, before I make a decision, I notice, okay, what is the distance at right hand side where I can have a junction or a station? How long my right side train should travel back side to reach a station? Let's assume it's a 10 miles. And for how long the left side train has to go back to get a junction? Assume the left side train has to just go back to 3 miles to get a station. Then it is very clear that we don't ask our right side train driver to move his train 10 miles, right? Instead that we ask our left side train driver to move his train back to 3 miles because he can just reach it very quickly. So the same way SQL Server will decide the query that going to roll back quickly. Okay, whatever the query that will roll back quickly, your SQL Server will kill that particular query. So in these cases, having said that, your SQL itself resolves it, it treats it as deadlock and it will kill those transactions. But how we will be involved in that? So as a DBAs, we need to ensure and we need to explain the user A and user B. We need to tell them that execute your queries in sequential order. Don't execute the queries at the same time. First, user A, you complete with your transaction. It might take hardly 1 or 2 minutes, and then user B, he executes its transaction. That's the only solution for deadlocks. The queries should be executed in sequential order. And one other thing is that's at database level, you can find it out. And next, the query level. Okay, if you want to fine-tune at query level, there are some standard process. Quite few people noticed that in your query, avoid excessive joins. That's the one thing. I'm just making a note here. At the query side, if we have to fine-tune it, the basic standard process we recommend for the end users who is writing those queries, we ask him to avoid excessive joins, and we ask him to avoid pulling unnecessary data. Unnecessary data is something, you have a students table and you want to see the student's name in that table. Okay, so usually what we do is, by default, we try to write a query saying that select star from table. Okay, even though you are only concerned about one column data in that table, but when you write star, your SQL Server has to pull all the rows and all the columns, even though you are not required, but you are pulling it out. So it's advised to pull only the required data. And the next thing you're gonna check is whether the tables in that query got indexes. Indexes will improve the performance of the queries for reads, so you need to check whether there are any indexes available. If index is available, the next in-depth about this is whether those are using properly or not. The existing indexes are using properly or not. And the next thing you're gonna check is missing indexes. Even though you have one index on a table, on a column, I have a table with 10 columns, and I have an index on first column. Okay. Now the user is executing a query something like select star from table where column 2 equal to XYZ. So in where condition I'm using column 2, but the index I have on column 1, right? So even though you have an index on a table, that particular index doesn't satisfy my query. My query is trying to pull out data based on column 2, and column 2 doesn't have an index. So we need to find out missing indexes. If you notice, uh, quite few people are executing queries more often on a column that doesn't got an index. So you need to think and plan to create an index on that column to get a better performance. And then after, we need to check the execution plan. Guys, please bear with me another 5 minutes. We could finish off that. So the next point is the execution plans. We need to check the execution plan. Execution plan is something like the roadmap, how the SQL executes your query. Probably you are executing a query like select star from employee, join department, where department equal to finance. So ultimately you want to pull out all the employees who fall under finance department. But you don't have the department information and employee information in single table. You have employees information in employees table, and you have department information in department table. So you need to join these two tables to get the data what you're looking for. So when I write a query, I'm writing in a manner that join table A, let's join employees with department. So I'm first giving employee. That means your SQL Server will first has to go and read the data from employees and match it with department data and then give the result back to you. So this is how I'm writing the query. Okay, but SQL will not execute the query in the same way how you write it. You are asking SQL to first pull out the data from employees and match it with the department. But SQL, it's not mandatory for SQL to use the same query what you have given. So SQL Server internally creates some execution plans. Execution plans is nothing but a roadmap. How soon, how can I execute this particular query in efficient way to get the results in fast? The best example is if you want to travel from maybe from Chicago to New York. If that was the task given to you, what would you do? You will find out the ways from which way from which city if I pass I will go quickly. If I go from a different city, let's say if I'm passing through city A, it's gonna take around 600 miles, and the same thing if I pass through city B, it's gonna take 650 miles, and if I use the third city, it might take around 550 miles. That's what usually happens if you try to check in Google Maps. It does give you multiple ways to reach your destination, and we pick up the best destination where we reach quickly with less amount of driving time. So in the same way, SQL will pick up the best execution plan depending upon the resources it got. So in my query, I gave the employee first and then department table. But SQL might think that okay, that is not perfect. Let me take first department. From department, let me pick up the people who are in finance and map it with the employees table and pick up the names. Probably SQL might think that is an efficient way, and it executes on its own plan. So in order to check, sometimes what happens is users execute some query and they come back to us and say, oh, my query is taking a long time. And you check all the things like the blockings, there are no blockings, but still the query is taking a long time. Then we need to check how your SQL Server executing that query. So we can do by using that execution plan. So if you look at here, there are some graphical icons. So this is a estimated execution plan. Estimated is something like it won't execute the query. Let me write a query here. See, I have written a query called select star from table underscore test. It's a straightforward query and I don't have any data in that. So if I click on estimated execution plan, it will give me the execution plan only. It will not execute that query. Okay, it only checks the query and it compiles it and it generates an execution plan and it gives it to me. And I do have a one more execution plan which says actual execution plan. So when I select actual execution plan and execute it, it executes the query first. You can see it executes the query first and then it gives the execution plan. And execution plan always we need to read from right side onto the left side. So let me use a table which has got some data. Okay, let me pull out the data from employees here. Or else yeah. So I've got around 290 records in this table. So if I use estimated execution plan, you can see it did not execute the query. It just gave me the execution plan. And in this execution plan, we have to read from right to left. So we need to start reading from right to left. So what is the extreme right? It is a clustered index scan. So it clearly says that this particular table has got clustered index and clustered index being used. And one thing we need to remember here is we should not see a task saying table scan. So we should not see a task saying table scan. Table scan is something your SQL is trying to read each and every row in the table. It's not a good thing. So if you see a table scan, it is a time for you to create index on the table. So if you move your mouse on this particular task, it will give you more information like how much CPU and how much IO and how many number of rows it got retrieved. So everything will be available here. And we talked about update stats, right? So if you won't update the statistics regularly, then the value for estimated number of rows to the actual number of rows will be different. So the example is, if I mislead you saying that the distance from Chicago to New York is 100 miles. If I mislead with this, what you do? You think that okay, it's just 100 miles, then probably I can ride on a bike, right? But once you start riding on your bike and once you reach 100 miles and then you realize no, What are the information I provided? It's a false. You then realize, oh, you still need to travel around 500 miles. So what you do in that situation, you go further, right? So in the same way, if you don't update your statistics, and while generating the execution plan, SQL uses those outdated statistics information and it proceeds with the execution plan. Assume that my table has got 100 rows now, and probably I have updated the statistics at the moment, so it's up to date. And probably now, from now to next 20 days, I have inserted some 100 million rows in that table, but haven't updated the statistics. So after 20 days, if I execute the query, my SQL will go and check the statistics first. So as the statistics were not updated, so the old information it got is 100. So my execution plan, what it thinks is, oh, this table has just got 100 rows. So let me use a base execution plan. I don't need an efficient execution plan because it just got 100 rows. It doesn't matter whether I use an extreme execution plan or a base execution plan. I don't want to use more time of thinking for an execution plan. So that's what the behavior of the SQL. And it just goes with a basic execution plan, and it starts reading from the table, and at one fine point it realizes, oh, it's not right. What are the stats said it got 100 rows? It's not right. It has got some 10 million rows. Your SQL server will keep on struggling to perform or to execute that particular execution plan. So that is the reason we always need to update our statistics regularly on the tables. So this is overall about the performance tuning, and one more thing is a DTA, database tuning advisor, is something like whatever we have created trace files using your SQL profiler, you can upload that trace file on database tuning advisor. So you can find the database tuning advisor in the same place under SQL profiler. You can click on it. You can connect to a SQL instance, and you can see here file. If you have a trace file, you just need to browse your trace file here, and then you can run it. You can do a start analysis. Then your tuning advisor itself do analysis on those trace files, and it gives you recommendations saying that, okay, if you create an index on this particular column, it will boost up the query by 30%. Or it says like, okay, you create an clustered index on this column and it will increase the query by 5 times. So that's what the recommendation the DTA will give you. So you don't need to bother about how do I make a decision to create indexes. You just need to create a profiler trace, upload that profiler trace here, and then do a start analysis. SQL itself does analysis and give you the recommendations. I understand it would be very tough to know everything on a single day, but hopefully I think you have got a bit idea about this performance tuning. So any questions? Can you show command to know the user blocked query? I just shown you dbcc input buffer. So this is the query you need to use. What is a quorum server? We don't have any quorum server. We have a quorum drive in cluster. We don't have any quorum server. So any more questions? I have sent you the links, the YouTube links for the always on and the cluster, so you can go through them, and I- if you have any questions further, I'm probably having said that this is the last class for this training, but still if you have any questions further, you can drop me an email, so I will reply back. What are the day-to-day tasks DBA perform daily? The day-to-day activity is something like you need to ensure all the backups ran successfully for last night and all the jobs got succeeded, and your SQL server is up and running, your databases are online and accessible, and if you have got mirroring or lock shipping or replication or always on, they are working in a proper state, and you don't want to see any login failures, like you have to frequently check the error log files of the SQL. So those are all day-to-day activities you have to do proactively. Apart from that, you might get requests from users. They will raise a tickets asking you to provide logins, permissions. They ask you to do a database refresh from production to UAT. You have to take backups and do a restore. So those are all on-demand requests. How often we monitor? We have to monitor all the time. If you have that's what the benefit we're gonna get using a third-party monitoring tools. If you have a third-party monitoring tool on your server, whenever there is an issue with your server, it automatically trigger an email to you. How to prepare for interview? Probably what I can say is, if you are very much prepared or very much aware about the topics which were covered in this training, then I would ask you to Google something like, if you are very much familiar about backups and restores, okay, you are able to back up the database and you are able to restore the databases, then I would suggest you to do some Google and check issues with backups and restores. If you Google with issues with backups and restores, there might be some forums. There are quite few forums available. So if I'm a user, I had got some issue while backing up a database, so I will post my question in a forum, and the one who is already into that issue and resolved, he will reply it back. So my suggestion for you is, probably these days in interview they will ask you, okay, what are the challenging things you have done? So you should have at least one or two things that you could explain. You have to explain something like, okay, while taking a backup, I have got so and so issue, so I have followed, okay, 1, 2, 3 steps to resolve it. So you can find all these things in, you can just find it in Google. You can search with the keyword saying that issues with backups and restore. Let me show you. If you just type this way, you can see there are some top FAQs, top 5 SQL backup and recovery problems, and troubleshooting SQL backups and restore problems. So there are quite few people might be posting requests on the forums explaining their issues. No, I don't have any basic interview questions. I mean, it ultimately depends upon how many years you are. If you are just making around 3 to 5 years, probably the basic interview questions might work. But if you are making around 9 years or 8 years experience in your resume, probably you need to practice well. You need to really configure mirroring, and you need to really configure all lock shipping. Then only you can answer the questions. It's not something like you read FAQs and answer it. If you have practiced the configurations, and if you have really installed multiple instances and you have done backups and restore, then it will be very easy for you to answer the questions. So any more questions? But still I try to find out if there are any interview questions that I mean, you can still Google it, even the same thing I do. So you can find number of questions. You can see for senior DBA, for developer DBA, top 10 questions. So you can just go through this issue with the solutions and try to understand. You don't need to go through all the issues. What I suggest is at least try to understand uh, two issues from each topic. Maybe pick two issues from database mirroring, pick two issues from log shipping, from two from mirroring. So at least make a documentation from your side about the issues, so that if someone put you a question saying that, okay, what are the issues you faced in log shipping? So you should be in a position to explain, okay, this is what the issue I have got and this is how I troubleshoot it. Does it make sense? Danish, I don't have any theoretical, okay, you mean to say theoretical topics. Having said that, the same thing, I have to browse on Google and give it to you. What are the topics we have covered? If you have configured database mirroring or log shipping, I'm saying again and again, you don't need any theoretical topics. If you have done a practice, you don't need a theoretical topics. If you have not done a practice, then only you need a theoretical. But still, I try to find out a couple of documents on internet and I will share it with you. Okay. Okay, guys, I wish you all the best for your career, and don't hesitate me to reach out if you have any questions. Google has complex explanations and getting more confused. Navnita, yes, I mean, we are at last class, so what I think is that's the reason I'm always stressing on every class asking you to do a practice. If everyone have done if have practiced mirroring on the same day, then I would clear all my doubts in the next 1 or 2 days. So try to practice everything, and if you still have any questions, you can reach me out. Okay guys, thank you very much.